This morning, I uploaded the third competition on the Kaggle. And if you go to the YSEC, there is a notice, the Kaggle competition, the final one. And as usual, we have just the URL. So let me go to the third competition to see what's inside. So this is the financial engineering competition, the third one. And for this problem, it's a combination of regression and classification. So here is a short description. So in this competition, your job is to predict column 5, which is the same as the previous one. And also you need to predict the column 8. And I'm going to show you what column 5 and what column 8 shortly. So before we go into the data set, the column 5 is a continuous variable. So which means we need to use the regression technique to predict the column 5. But column 8 is a discrete variable. So it has only 2 values, 0 or 1. So in order to predict the column 8, this is the classification problem. So you need to classify whether the given data is in category 1 or in category 2. And of course, yeah, there is, so this is a little bit a bigger version of the competition 2. So in competition 2, there are over 7 columns, and the column 5 is the target we are going to predict, but column 3 is missing. But here the third competition, we also have the column 3 is missing. I don't know why this is so big. Maybe I'm going to open another one. So let's take a look at the data set. So in order to participate in this competition, you have to agree the competition rules. Okay, here is the submission files. So you have an ID, and you need to predict the column 5 and also the column 8. So this is just a sample submission. So I just put all the same number for the column 5 and column 8. But if you see the training data set, the training data set, all the values from column 1 to column 8. And here column 8 is our classification target variable, and column 5 is regression target variable. So there are total, the useful columns are 8. But if you see the test column, the test data set, it has column 1, 2, but there is no column 3. But column 3 is not our target, but it's just missing. And column 5 is our target, and column 8 is also our target. So go to the description again. So even though there is no column 5, the column 3 in the test data set, predicting column 3 will help you predict the column 5. And this is actually the second competition. So today I'm going to talk about the second competition in more detail. But before we go into that competition 2, if you have any questions, please let me know. And yeah, also I uploaded the lecture on 2 weeks ago on the YouTube, so you can find the link in, I think it's around here. Yeah, it's a lecture on December 6th, and you can go to the YouTube channel to see what I told you before. No questions? Okay, then I'm going to go into the second competition and go to the notebook. And I'm going to make a new notebook. So I can select the language, the notebook type, and I will create my notebook. Okay, let me change it to today's date. Okay, I have a question from you. Okay, you tried the early stop, and according to the logic, it is supposed to decrease the error, but it was not. Okay, I'm going to explain, what early stop means. So let me go to the TensorFlow and search for the early stop. Then we have a link to early stopping. So the simple explanation for early stopping is stop the training when a monitor metric has stopped improving. So this is one of the techniques that reduce the number of iterations. If you if you approach the bottom loss. So at first we do not know how much iterations do we need, so we just increase the number of epochs and watch how our loss function is decreased. But if you have enough number of epochs, then you may apply these early stopping rules. So there is some, if you want to use the early stopping rules, you need to know, you can try it in some tutorials or guide. But early stopping does not help you to decrease the loss. It just controls the number of epochs. So we expect that our loss will be decreased at every epoch. So let me draw a graph. So here is loss, and this is number of epochs. And the usual situation we are expecting is that it is decreasing. But since it takes too long to see what's going to happen at the end, you can apply the early stopping rules. Then the early stopping means that it just stops at here because it does not show any much improvement from your matrix. Then it stops here. It does not help you to decrease the error. So for this question, yeah, it is not supposed to decrease the errors. It just monitor the decrease of your loss, and if it does not be if it is not improved, then it just stop. So that's the meaning of the early stop. I will explain the code for the competition today, but probably I will not upload the code because but I will upload the lecture itself to the YouTube. So do not wait for my notebook to be uploaded to the competition. Just listen carefully during the lecture and try to follow what I'm trying to do. And then if you can understand during the lecture time, then you can review the YouTube channel, the YouTube video, and then it's not enough just to watch the YouTube video. You have to pause the video and do your own work, and then proceed and pause the video and do your work again and again. So that's the way we learn something. Why DNN can replace other models? Did I say that? Well, maybe, yeah, what I was trying to say is that DNN is very flexible model so that it can functionally replace the other models, not exactly replicate the other models. So, actually, yeah, that's today's lecture, because for some other models, if you are trying to use, and that model can do just one specific things, and you cannot extend the other models. But the neural network model is very flexible, so that it can take two different kinds of inputs, and it can also produce several kinds of outputs. So that's the technique that I wanted to show you today. So I'm sorry, but yeah, I can understand your question exactly. So if you want, ask me again to be more specific, then I will try to explain. Why did I use RMS, not MS, RMSE, not MSE? Okay, that's simple because when I make a Google Kaggle competition, the first option was the root mean square error, so I just chose that. But if I really wanted to use the MSE, then I can I might change it to the MSE. But if you take the square root of the MSE, that's the RMSE. So for me, it's just the same thing. So it just one number is just take a root of one number gives you this one, and square it gives you this number. So why did I use it? Yeah, because it's on the top of a list that I can choose. Okay, if you don't specify the batch size, what is the default batch size? The default batch size is 32. And sometimes it helps you learning, it helps you training, by changing the number of batch size. But for me, I don't think yet that's very critical. So I did not explain how to specify the batch size, but the default is 32. And the so you may try to change it to a different numbers, but the 32, the next number of 32 is 64. And since this is the computer, it's 2 to the power of something. So if you use just a batch size for 60, it's equivalent to, it's very similar to 64, because the number of the batch size is bigger than 32, then the speed is almost same as the 64. So you don't have to use, it's a better idea to use just the 2 to the power of some numbers. Okay, let me show you the the leaderboard. So right now, you cannot see the private leaderboard, but I can see both. And by looking at the both leaderboard, you understand, why that kind of thing is not so important. Okay, so this is the public leaderboard, and there are students, and their scores are here. So the top is 0.018 and 0.02, 0.02, 0.02, and let me show you the private leaderboard. So it's 0.019 and 0.02, 0.02, and the third and the second and third are the swapped, but the difference is really small. And as you can see, some students might go up and some students might go down, but that the change is not so significant. So just try to go up to the public leaderboard, but say point. So basically, these are the same. So I think the older students from 2 to maybe 22 or 23 are basically the same. My recommendation is the DNN model, because for the first competition, you might use some other models, like the one from the scikit-learn, and you can use the special regressions for their competition. But if you still wanted to use that specific model for the second competition, then you will get in trouble, because for the second competition and for the third competition, you not required, but I recommend to use the deep neural network model, so that it can be easily incorporated multiple inputs, or the output will be the input of the another layer. That kind of thing you can do very easily to the deep neural network models. I recommend you to remove the ID column, because ID column is, every column is unique. So it does not help you predict your predictions. So my recommendation is, remove the ID columns. Because, and there is a way to cheat, but that cheating technique will not be successful for the private leaderboard. So okay, let me this is a good chance to explain what's inside the data. So ID column is unique. So let's say it's 2, 10, 5, and there are some numbers. And actually there is a answer for example, for the 20, the answer is 20, it's 100, and it's 50. Of course, we do not know yet this number, but if you include your ID column in your regression model, then it may help you to predict this number. But since we divide it, and from this simple example, you realize that okay, the times 10 is always the answer. You can see. But in real problem, it's not times 10. Yeah, it's another number. So if you are successful for successful for using ID in your public score, the private test data set does not help you to predict the actual value using the ID. So yeah, it's better not to use the ID column. Yes, that's right. Yeah. So the minimum, the default number is 32. And then the next number is 64, and next number is 128, and so on. How many people get an A+? Last semester, I gave 85% of the students an A+. Well, I'm not sure, what is your score for the loss, but I can say right now, if your score is less than 0.02, which is just one student, you are fine. So try to minimize your score, the 0.02. So all the other students above all other students, so that's because achieving this number is pretty simple. So do a little bit more, then you can increase your score. You can actually decrease your score and will be ranked on top. Okay. So let me go to the second competition. And as usual, I will run the first cell to see all three data set. And then since I'm going to use the TensorFlow, import TensorFlow as TF. And from TensorFlow import keras, and from TensorFlow import TensorFlow keras, from keras import layers. Because we are going to use the TensorFlow, yeah, you have to import the TensorFlow, but also we are going to use a lot of keras and layers. So without this, the last two import, we always have to write TF keras layers, something, but here we don't have to. And then my first data set is PD read CSV, and I'm going to read my train. So import the library and then read the train data set and see what's inside. And we have from column 1 to column 7. And in this competition, we are going to predict column 5, but column 3 is missing. So I'm going to divide this training data set into the features and the target. So first, I'll want to make a copy. Features is df.copy. And I want to take the column 5 out. So my column 5, variable column 5 will be features pop column 5. And I also pop out the column 3 and save it to another variable named column 3, because I'm going to use column 3 later. So it's feature dot pop column 3. And since I said before, I'm not going to use the ID, so I also take the ID out. Features pop and ID. So okay, let me see. So df is still the same form, because we just make a copy of the df and save it to features. But since we take out several columns from features, the features has only column 1, 2, 4, 6, and 7. And I have to remember how many columns that I'm going to use, which is 5. So I'm going to use this information later when I make the DNN model for the input. And then the column 3 is, it does not have a column 3. Oh, I did it wrong here. Okay. And so I have to run this part again. So that's the reason why we make a copy. Because if I just change this part as column 3, then it will gives me an error, because I already took out the column 3. It doesn't, the features does not have the column 3 anymore. So that's why I make a copy and column 5, column 3, and pop out the ID and df, features, and column 3. So column 3 is here, and also I can see the column 5. Okay, question. Okay, a little bit slower. Okay, column 3 is missing. So what I mean by column 3 is missing is that, well, this time I'm gonna read the test data set. So PD read CSV and test data set. So in test data set, we don't have column 3. So the original training data set has all the columns. We have all the columns, including column 3 and column 5. But since our final goal is to use the trained data set, I mean the test data set, to predict column 5. So I intentionally take out these two columns, column 3 and column 5, from the training data set. So column 3, it looks like the column 3 is still here when we look at the DF, but features column does not have column 3 because we save it to another variable. So that's what I mean by the column 3 is missing. So I might be fast, but okay. So let me do it from the beginning. So it's a read or what's inside the directory, and we import 3 things, and then read the train.csv and save it to DF and see what's inside the DF. So it's ID, column 1, 2, 3, 4, 5, 6, and 7. And then I make a copy of the original data set and save it to features. And at this point, the features are exactly the same as the data frame. And by taking out some columns from the features, the number of columns will be reduced in the features data set. So the way we take out column is features.pop. And specifically, I would take out the column 5 out of the features data frame and then save it to a variable name column_5. And do a similar thing for the column 3. And since I don't need the ID, so it's features pop ID. So I did all my required operations, and I just want to make sure that I am right by looking at the data set again. So the DF has all the columns and features. Since I took out ID, I took out column 3, I took out column 5. The features data set has only 5 columns. And those columns that are out is one is column 3, and the other one is column 5. And I don't save the ID columns because I don't need the ID columns. So I'm gonna delete this part. Okay, then we are ready to build our Keras model. So how did we make our model? So we usually do something like this. It's my model dot tf keras dot sequencer as sequencer. And then write, some layers, and layers. But today, I'm going to show you a different way. So first, I'm going to define my input first. So its name is my input. And I specifically say that I specifically say the input layer. So it's keras dot input. No, it's just the input. And since I make a explicit input layer, I need to tell how many inputs I'm going to have here. So that's the way, that's the reason I have to write the shape. And shape is 5, comma. You see, why 5? Because column 1, 2, and 4, 6, 7. So I'm going to have only 5 columns. So I have to tell my input layer that the shape is 5, comma. And you know what this means. It's a tuple. So this is going to be my input. And then, so basically, let me draw first. What I'm going to do is to make a DNN model. So this is going to be my input layer, and then another layer, another layer, another layer, and finally an output. And if you think that this layer is a function, it will have an output, and that output will be an input of the next layer. And then it will produce another output, and this output will be an input to the next layer. So let me write this idea explicitly in the TensorFlow code. So first, y is layers dot dense. And note that the input, the I is capital letter and dense is a capital letter. And some layers, does have the lowercase letters, but usually they have the capital letters. And in the dense layer, I can specify how many nodes I will have in this layer. So I may say 128. And then I wanna say my activation function is relu, and its input is my input. So right now, it seems a little bit odd, but let me explain by adding some more layers. So I'm going to make a copy of this one and put it in the next line, and well, just 3, or 4. And first, I'm going to change the number of nodes. So it's 64, and then 32, and final one I would just like to have 1. And for the final one, I don't need the relu activation. And still, this is I have to explain some more. So first, let's take a look at the first line. its a first line says that there is an input layer and there will be 5 columns. And then I call this one as my input, and then put my input as an input to this layer, and then it will produce the output Y. And then this Y will be the next input of the next layer. And then it will produce an output named Y again. And this output will be an input to my next layer. And this output will be the input of my next layer. And then finally, I would have my output. So this is the another way to build, to add our layers. And then finally, we have to say, okay, this is my first model, because today we are going to make several different models. I'm gonna say this is my first, this is my first model, and then it's Keras. And remember that when we build a sequential model, and we have to say Keras dot sequential, but the code that I showed you just before is it's a special case of a very generalized model. So instead of writing the sequential, we have to call it model. And then I have to specify what's my input of my model and what's my output of my model. So it says inputs is my input, and its outputs is my output. And then also, yeah, and every layer I can actually give some specific names. So for example, this model's name is, yeah, it's my name, Juchal. And you can use your name. And then before I execute this one, I wanted to see how does it look like. So first, model dot summary. Okay. Can you scroll it from the beginning one more time? Yeah. Sure, I can. But even if you don't see the screen, you should, this is a very natural way to build our data, the data sets. So first we read what's inside, and then import libraries, and then read a file from the directory, and then to see what's inside. And then this is the part. So I want to make it to X, and so yeah, I want to make something to be my input columns and something to be my output columns. So the reason why I use the df copy is that sometimes I made a mistake. So I just want to keep my original one and then make a copy of the features data frame. And then at this point, the features data frame has all the columns, but when we take one column out of the feature column, then those take out column will be saved in another variable name, so column 5. And those column 5 will be removed from the features. And then we also take out the column 3. And then since we don't need the ID, we just take out the ID. And then to see to verify what's inside. So I just wanted to see what's inside. I'm going to run. Wanted to see what's inside the DF. So DF has all the columns. And then since I took out several columns, the features column has only 5 columns. And I wanted to see the numbers. Want to verify the numbers in column 3. And those are the number that I saw. And column 5 is some numbers point it's 0.1, 0.2, and some numbers. And then I define my model here. So I run it, and you will see the structure of my model. And let's compare one by one. So the first line is I define an input, and the input says the number of input will be 5. And actually, this input layer does not do much. It's just a define or input layer. And so the number of parameters here is an input layer. The first one is there is no parameters. It just deliver the 5 inputs to the output. So the output shape is none, 5. And don't worry about the none here. It's just it's the number of batch size, but we don't have to batch size at this point, so it's just none. And then for the next layer, it takes my input, and then it has 128 nodes, and then its output will be Y. So it's written here. So the output shape, 128, is equivalent to the number of nodes, and its dense layer. And it does not show what kind of activation I use here, but yeah. And then take this output to the next one, and take the output to the next one. And as you can see, the output shape is this, and this, and final one is since this is layer of just one node, it has 1. So it's just another way of saying the sequential model. So you can do exactly the same thing for the sequential model, but the reason I showed you in this way is that later today, so you may recognize that here inputs, here is outputs. It's not just the input and output, it's a plural form. That means we can put several inputs inside, and we can also take out several outputs using this model. For sequential models, there is only one input source, and there is only one output source for the sequential model. There is no way to make 2 different or even more than 2 input input stream to the sequential model, but here it is possible. But in our simple example, we have just one input and one output. And this is the result. And how can we how can I make this model run is just this one. So firstly, we need to provide some more information. So my first model dot compile, and we need to tell the loss is okay. Let's say it's just the MSC. Okay, I'm gonna so today I'm gonna be more specific. So it's keras losses and mean squared error, ER. And optimizer is keras optimizer or optimizers optimizers dot, let's say Adam. So this is the way we provide some informations. So we can just write, yeah, the loss is quote MSE and optimizer quote Adam. But the reason I write it in this way is that I'm going to show you how can we add more than 2 loss functions inside one model. So I just wanted to show the simple cases first. And then in order to fit, so it's first model dot fit, and the fit needs at least 3 inputs. The first one is the X and Y and number of epochs. So what was our X? It's features. Features. And then for this case, our Y is column 5. And number of epochs. Epochs is, I just want to make it 2 because, and this is a very good start because if you specify 1, then it runs once. And sometimes there might be an error. Just, yeah, the problem might occurs when you move to the first epoch to the second epoch. But if you are successful for 2, then you can increase it to 2,000, yeah, 2 million, whatever number you want. So this is good to test about my model is actually working or not. So it is working. So at this point of time, I don't care about the actual the value of the loss. I just wanted to show you how to build up models. So this is the end of the first model, and let's take a break. And then I'm going to show you how to modify the model and how to incorporate more than 2 inputs and how can we produce more than 2 outputs and something like that. So we will be back at, well, 3:10. It's 3:10. Of course, if you have a question, then leave your question on dementi.com. And when I come back, I will answer your questions. And for some of you wanted to see the code. So okay, I'm gonna make it into just one cell. So this part, yeah, that's the main topic for today's class. Okay, we'll see at 10, no, 3:10. I want to show you what I wanted to do for this second competition. So we are going to use the column 1, 2, 4, 6, and 7 to predict column 5. Okay, yeah, there is a question. Oh, thank you. So this is the second competition, and the first competition, yeah, we had the number 3, but I intentionally omit the column 3. But if you have column 3, then your prediction will be much better. So first, I might try to build my model to predict column 3 first. And then, so this is going to be my input, and then this one. And then once I have this column 3, then I might make another model to take this one as my input. And I'm going to use, yeah, the same one again here, 6 and 7, build another model. And since, yeah, I have the 5 columns, my prediction might be much better. So this is column 5. So let me see. So this is what I wanted to show you. See? So how can you make this kind of model? So this is the topic of this lecture. So we know how to make the Keras model, and in Keras model, we can specify what is going to be my input and what is going to be my output. And if you have this model, then you may think that this model is actually a one layer. So what I mean by one layer is that once we have this one, you might call this is just, yeah, my first model. So you may think this, my first model, is another layer so that you can build up, yeah, from this layer. So it's better to show you here. So let me see. I just make a copy of this part. And write it here. And so it's my input and my output. But this time I'm going to change it to my input 1 and my output 1. And actually, it does not change the shape of the model, but it will still take the 5 inputs and then produce just 1 output. So this is my code for the one model, and then I can make maybe another model, and I'm gonna change it to it's my input 2 and it's my output 2. So the first my input and my output 1 will represent this part. And then, so this part is, the thing related to my input 1, my output 1. And then this part will be the my input 2, my input 2, and my output 2. And then I need to combine these two in somewhere here. So I'm going to add one layer under my input 2, and that layer is going to be Y and layers. And this one is special, concatenate. And concatenate means combine some two things. So what I'm going to combine. So first one is output 1, and then my input 2. Oh, this is my output 1. So this part is a new one. Okay, I have a question. So how is it different to voting regressor or combination of DNN models? The voting regression or voting regressor is something like this. You have one regression model, and you have another regression model, and many different ones. And all of these have the same input, the same input. And then it will produce different output because the models are different. And then voting regressor means that just take one of these based on some criteria. But what I was trying to do is that make a model, and it takes, say, input 1, 2, 4, 6, and 7, and then use that output, and then original 1, 2, 4, 6, 1, and then the combine, it's concatenate, and then make a model. So these two are not related. The problem, I think this TensorFlow is better than the other one, is that you may try to make something similar to this one with TensorFlow. So how can we do that? So you make lots of layers, and you make another lots of layers, make another lots of layers, and then use the output, and then make another layers to produce your output. But if you use just one voting regressor, then you cannot make this kind of things. Okay, why is it input and output, not both input and input? Okay, So that's the way we use our previous, the two models together. So you have input, and based on this input, I'm gonna make actually column 3 instead of column 5. And then here is the input, and then I'm going to use this column 5 as input also. So this is the concatenate layer. Concatenate. So this column 3 is the output of first model. And this is the second input. Actually, this input is same as this one, but I just call it its input 1 and it's input 2. And this one is output 1. And the final result that I will get is actually column 5. So if you can understand what I was trying to draw here, then you don't have any problems, because for the concatenation layer, I need output 1, and I also need input 2. And both of these will be concatenated, and then it will be an input to the next layer. Okay. I don't know. Let me take a code, but before we that. Okay, I might have a problem with my code, so let me see. Oh, okay, you're right. So this is right. Now you start to understand what I was trying to say. So there is a mistake. So this is the input layer, and that input layer name is my input 1. Then I have to put my input 1, and then it will produce output, output, and then final output will be called, the intermediate output will be called my output 2. And then I define another input layer, and then I take this my output 1 and my input 2 as another input. So this is the concatenation. And then I think I have to change this part also. So this is why. So because I want to take the concatenated output to be the input of my next layer. So in this way, I made my layers, and then now I need to build my second model. So it's a second model, and TF, not TF, keras dot model. And since I have two, so remember that I said it's not just the input, it's inputs and something, and outputs and something. So if you have just one input and just one output, then we don't need this list. But since we are going to use several input and not several outputs, but it's okay to use the square to make it a list. So what is my input? It's my input 1 is my input to the whole model, and then my input 2 is input of my whole model, and my output will be, say, my output underscore 2. And I'm not sure if this is I'm not sure if this is correct or not. So in order to verify that, I need some other functions. So it says keras.utils.plot model. So even for me, I don't remember this function, but I knew that there is a function, something like that, and then I go to the TensorFlow and try to find this function. So don't try to remember that, but if you are fluent, then you will remember that very easily. Show shapes is true. Okay, so this is basically the plotting your model. So let me show you what it says. Okay, there is an error. Graph disconnected. Yeah, so it means something is wrong. I don't know where is wrong. So let me keep my input 1, and it says my graph is disconnected. Input 2. Why? The second model. Oh, this one is disconnected. Yes, yeah. Because, yeah, I should say my output. No, my output 1. Yeah. Yes, this is right. So it shows you a graph. So let's read the graph. And we don't have to worry about the input 4 or dense 12 bits because it's automatically named. So this part is my input 1. And then it goes to dense layer, dense layer, dense layer, and output. And this is my output 1. And then I have my input 2, and then these two are combined here in concatenate. And then those 6, you see the number is 6 because 1 is from the output 1 and the other 5 come from the input 2. So total 6 will be used for another dense layer, dense layer, dense layer, and output. Okay. Really? But anyway, yeah. Yeah, maybe you are right because do I need to add this part? Yeah, it should work. Okay, yeah, that's the actually, yeah, that's the actually, yeah, what I wanted to show you before this one, because you can make in this way. So the input is input 1, input 2, and output is only my output 2. Okay, and there is, yeah, nothing has been changed in the model. And I'm going to show you this one first, and then after showing you this one, and I'm going to explain why I can add another output here. So for right now, yeah, this is let's suppose that this is our model. Oh, okay, yeah. From the top again. Okay. Okay, the correction, yeah. You don't need a correction. The meaning of the last line, the second model. Okay, these 3 cells is what we are doing now. So yeah, there is some there was something was wrong with me, but just look at really carefully. So you have to be careful. And the meaning of this one. So basically what I was trying to do is build a model. I'm gonna draw it a little bit smaller this time. So 1, 2, 4, 6, 7 is our input. And we are going to make a model. And then this is going to be output 1. And 1, 2, 4, 6, 7. And then we concatenate. So concatenate means, it's just to make a big row. And then make another model, and then put it to produce output. So this is what I trying to make a TensorFlow code. So this part is in the first cell, and this part is in the second cell, and on the third cell, I said my second model is keras.model, and then I need to specify the input, and I need to specify my output. And then I'm going to show you, another version, but here I just said my output is just this one. And for my input, if you see this one as a big whole thing, then what are the input of this model? This is your input, and this is another your input. So these two are your inputs. And then inside this concatenate layer, we need to take the output 1 and then this input as our input for this concatenation layers. So look at the code and try to try it. Well, maybe you can take a picture with your phone, and then if I go to the other line of code, then you can see the widening by widening your pictures. Oh, yeah. So that's why I'm explaining this technique. So for the third competition, you will need 2 outputs, but for the second competition, you need just one output. So, but in the meantime, you have to, it's better to predict column 3 during the building a model. So that's the point that I'm going to deliver today. So how can we make more flexible models, not just stacking the layers? Okay, so there are some students, yeah. Then go to the top of your program and run one by one again. And then be careful the my input 1, yeah, some are _1 and some are _2. So yeah, just take a picture of this screen. I 바로는 못 올려줄 것 같은데. So yeah, I'm going to show you my code. Take a picture. So maybe you can take a picture of this one and take a picture of this code. And it looks like yeah, we did a lot of things, but actually the code itself is pretty simple. So it was, yeah, we see what's inside the directory and import the libraries and read the data and then do some data manipulations and check whether they are correct or not. And then this was our first model. So it was a simple model, just stacking lots of layers. So input, dense, and output. And then we specify what is my input and what is my output. And that was the simplest case. And then these 3 cells of code is what we are, what I was trying to explain. So they are very similar to the first model. I just changed the name of my input and changed the name of my output. And then this one, I changed the name of my input again, and then add concatenation layer. And this concatenation layer takes 2 inputs. One is from the output of the first one, and then the original input. And then it will produce the output. And since this is just the description of your model, you have to explicitly say that, okay, I'm gonna make my model. And this line is this one. So maybe, yeah, just think about in the computer age. So this, the computer says that the Keras model, okay, so this guy is going to make a model. So what is your input? So my input 1 is input, and my input 2 is also input. And then computer says that, okay, my input is this one. Then what should I go next? Is here and produce this. And if this one goes to this, and then it will finally put the output 1. So the first model is the 5 layers here. And then the concatenation is here, and this model is trying to interpret this one. So it says, yeah, 1 from my model 1. Well, I don't know. Yeah, I'm repeating what I'm saying. Yeah, I did it. That Y represent the previous ones. So all of the previous one is represented by Y. So you may think that Y is just an output of all the previous information. So let's go to the very top. So there were just students who wanted to see from the very top. So import df, and data manipulations up to here, and then check, and check. And then this is our first model. And after finishing our first model, we took a break. And this is our second model. And in order to build our second model, I need the left side of the model and I need the right-hand side of the model. And that left-hand side is this part and right-hand side means this part. So why? Actually, this Y is, yeah, every time the Y is changing. And you may think that Y is just an output from the previous layers. So the first Y is, I don't know what it is, but it just say, yeah, it's an output from this layer. And this output will goes to as an input to the next layer. So the second Y contains the information about this layer and Y, but this Y is this guy. So maybe you can write it this way. Or maybe, yeah, I can write it this way, yeah. It's my output. So I'm going to rewrite this part. On the 1 is layers dense. I'm going to write, yeah, from the bottom. So layers, it's layer 1. And then what's the input? And its input is another layers dot dense dot 32 and activation equals relu and some input. And that input is another layer dot dense dot. So you can, yeah, make it a composite function. It's a function of function until you reach this part. So maybe, yeah, you can write it just, yeah, one line, but it's very, it's not easy to understand what it means. So instead of writing it this way, the people usually write it in this way because this is much easier to understand what is the input and what is the output. Maybe or maybe not. And if you fully understand what we are doing today, actually you can go to, okay, yeah, I'm going to go on to the third competition, but because this is the third competition is not just the regression, it contains the classification, and I did not fully explain what the classification problem is. So I'm going to do a very similar thing, for the third competition, but not today. Well, you may think that you did exactly the same thing, but probably there might be an error. So it's not an error. Even if you have the input 7 or dense 28, uh, uh, it's not different from mine. But what should have to be the same is the number of input and number of output. That should be the same as mine. Then yours are the same as mine. And for your information, you can actually go to the TensorFlow, and TensorFlow, get started with TensorFlow. And what I explaining right now is a little bit advanced. So it's not in the tutorial, it's in the guide. And in the guide, you can see here is a Keras. The first one is the sequential model, which we did last the previous lectures. And what I'm doing right now is the functional API. And there are lots of sections. So I made it a very relevant to our problems. So if you cannot understand what I was trying to say, then you may refer to this section, Keras functional API. And by now, you will realize that you can make very complex models like this one. So it has several input layers and several output layers, but the code itself is pretty simple. This one is all. So you have to say, it's a Keras model, and what is your input, and what is your output? That's it. And you have to define how this input is related to the other guys by saying that, something is the input. So there are 3 inputs, and there is a so-called embedding layer. And we don't need embedding layers, and we don't need LSTM, and we just need dense layers. So this is the way you build a model like this. And if you go further, then you can make a model like this. And the fun thing is that it's toy resonant. So it's a toy version. Even though it looks really complicated, but it is a toy version of a very famous network. And we can build that famous network by using TensorFlow and understanding what we have done so far. Yeah, that's right. And one more thing is that I'm not going to upload my code. So you have to understand the logic of how you make the model, and then you can try several different things. So I think, yeah, this might be a good uh, exercise for you, because you can uh, proceed without by skipping, yeah, some layers and then go to the next one. And this is the way we make our model. So at the first stage, it was really simple. Yeah, just a dense layer, dense layer, dense layer. But what if we skip some, yeah, layers and then direct your output to, let's say, yeah, 2 layers after that? We don't know the result. So that's all experiment. I'm sorry, but what does it? Uh, but what do these codes means again? I recommend you to watch the previous videos. Oh, okay. Okay. API is a very fancy name for function. It's an application programming interface, but it's just a fancy name for a function. No, I think, yeah, I explained uh, a lot. So probably I'm gonna stop here and leave some parts next week. How can I use 2 outputs, or because, yeah, right now I have just one output. See, there is just one output, and so this is not enough. So probably I'm gonna stop here and then give you time to experiment. And then if you are curious, then you can go to the TensorFlow guide. This time it's not the tutorial guide. And then Keras and functional API. Mhm. Okay. So how to make this submission file? Well, go to the previous video on the YouTube. You have to watch all the YouTube videos that I uploaded, and it will take, say, more than 10 hours. Not 24th. It's due 22nd. So don't be late. I'm not going to explain how to submit, because everything about the submission I did, yeah, almost 3 weeks, how to make the submission file and how to submit. So please go to the previous lecture videos on the YouTube and watch it carefully. And it will take, yeah, about 2 hours, but actually by watching my video, it will take more than 5 hours, because you have to pause the video and then practice. So without practicing your code, you cannot uh, do. It's very, yeah, hard to do your competitions. No, not today. Yeah, its due date is it's December 23rd, but the number of submission per day is 10 times. So, and the score, your score will be based on the best one ever. So it's so I think, yeah, it's good to submit more. Okay, this one, because it's not optimizer, it's optimzer. See, there is a spelling error. So that means you have to change your the compiler. Yeah, so maybe here it's optimizer. There is an I, and here is I2. So for this kind of errors, the invalid keyword errors, that usually means your spelling is incorrect. Oh, okay.